To ancient peoples, zero's mathematical properties were inexplicable, as shrouded in mystery as the birth of the universe. It is hard to imagine being afraid of a number, and yet ancient peoples were afraid of the number zero. Zero represents the void, nothing. Ancient cultures, from the Greeks to the Hebrews to the Norse, believed that emptiness and disorder were the natural state of the cosmos, and these cultures shared a fear that at the end of time, this void would return. Zero represented that void. While the Babylonians began using zero as early as 300 years before the Common Era, it would be many, many more years before zero would be accepted by the cultures that were considered the most advanced mathematicians of the ancients, the Egyptians and the Greeks. Zero was different from other numbers. The Babylonians never allowed zero to stand alone, for good reason. A lone zero always misbehaves, or at least it does not behave the way other numbers do. Add a number to itself and it changes. 1 plus 1 is not 1, it's 2. 2 plus 2 is 4, but 0 plus 0 is 0. Archimedes was one of the most famous of the ancient Greeks. He developed an axiom that says if you add something to itself enough times, it will exceed any other number in magnitude. That means it gets bigger, but 0 refuses to get bigger. Add 2 plus 0 and you get 2. It is as if you never bothered to add the numbers in the first place. The same thing happens with subtraction. Take 0 away from 2 and you get 2. 0 has no substance whatsoever. This threatened to undermine the simplest operations in mathematics, like multiplication and division. Multiplication is like a stretch, literally. Imagine that the number line is a rubber band with tick marks on it. You can think of multiplying by 2 as stretching out the rubber band by a factor of 2. The tick mark that was at 1 is now at 2. The tick mark that was at 2 is now at 4. Likewise, multiplying by 1/2 is like relaxing the rubber band. The tick mark that was at 2 is now at 1, and the tick mark at 1 winds up at 1/2. So, what happens when you multiply by 0? Anything times 0 is 0, so all tick marks are 0. The rubber band is broken. The whole number line is collapsed. There's no way around it. 0 times anything is 0. It's a property of our number system. For everyday numbers to make sense, they have something called the distributive property. Imagine that a toy store sells balls in groups of 2 and blocks in groups of 3. The neighboring toy store sells a combination pack with 2 balls and 3 blocks in it. 1 bag of balls and 1 bag of blocks is the same thing as 1 combination pack from the neighboring store. To be consistent, buying 7 bags of balls and 7 bags of blocks from one toy store has to be the same thing as buying 7 combination packs from the neighboring shop. This is the distributive property. Mathematically speaking, we say that 7 times 2 plus 7 times 3 equals 7 times the quantity 2 plus 3. Everything comes out right. If you apply this property to 0, though, something strange happens. We know that 0 plus 0 equals 0, so a number multiplied by 0 is the same thing as multiplying by the quantity 0 plus 0. Using 2 as an example, 2 times 0 equals 2 times the quantity 0 plus 0. But by the distributive property, we know that 2 times the quantity 0 plus 0 is the same thing as 2 times 0 plus 2 times 0. But this means that 2 times 0 equals 2 times 0 plus 2 times 0. Whatever 2 times 0 is, when you add it to itself, it stays the same. This seems a lot like 0. In fact, that's just what it is. Subtract 2 times 0 from each side of the equation and we see that 0 equals 2 times 0. Thus, no matter what you do, multiplying a number by 0 gives you 0. This troublesome number crushes the number line into a point. But just as annoying as this property was, The true power of zero becomes apparent with division, not multiplication. Just as multiplying a number stretches the number line, dividing shrinks it. Multiply by 2 and you stretch the number line by a factor of 2. Divide by 2 and you relax the number line by a factor of 2, and you undo the multiplication. Divide by a number and you undo the multiplication. A tick mark that had been stretched to a new place on the number line resumes its original position. We saw what happened when you multiply a number by 0. The number line is destroyed. Division by 0 should be the opposite of multiplying by 0. It should undo the destruction of the number line. Unfortunately, that isn't what happens. We saw that 2 times 0 equals 0. So to undo multiplication, we have to assume that the quantity 2 times 0 divided by 2 will get us back to 2. Same thing with 3 and 4. But 2 times 0 and 3 times 0 and 4 times 0 each equal 0. So the quantity 2 times 0 divided by 0 equals 0 divided by 0, as does the quantity 3 times 0 divided by 0 and the quantity 4 times 0 divided by 0. Unfortunately, this means that 0 divided by 0 equals 2, but it also equals 3, and it also equals 4. This just doesn't make any sense. Strange things happen if you look at 1 divided by 0 in a different way. Multiplication by 0 should undo division by 0, so 1 divided by 0 times 0 should equal 1. However, we say that anything multiplied by 0 equals 0. There is no such number that when multiplied by 0 equals 1. At least no number we've met. And worst of all, if you wantonly divide by 0, you can destroy the entire foundation of logic and mathematics. Dividing by 0 once, just one time, allows you to prove mathematically anything at all in the universe. You can prove that 1 plus 1 equals 42, or that William Shakespeare was an alien, or that the universe was created by a flying spaghetti monster. Multiplying by 0 collapses the number line, but dividing by 0, that destroys the entire framework of mathematics. There is a lot of power in this simple number, and eventually 0 became one of the most important tools in mathematics, against the wishes of some of the most important mathematicians and philosophers in history.